Area vector. Area is a scalar quantity. But for defining so many physical quantities, we consider area as a vector quantity. So see, what is area vector? You know how to write a vector? Magnitude into direction. So area vector is also written as magnitude of area into direction of area. This direction of area written as n cap. This is direction of area vector. Number one, now onwards for so many physical quantities we will consider area as a vector quantity and its direction will be written with n cap. So n cap is direction of area vector. How to find it out? It is outward drawn normal to given surface. It will be normal perpendicular to surface as well as it will be outward. Breathe in slowly and gradually. See as an example, this is one cube. Now cube having 6 faces, 6 surfaces S1, S2, S3, S4, S5 or S6. You may write them as 6 area vectors. Area 1, area 2, similarly area 3, area 4, area 5 and area 6. You know what is this magnitude of area? Magnitude of area, you know it already. You write it with mod of A vector or only A. This is simple area. Like it is one cube of side L each. So area 1, area 2, all the areas of this cube are equal. You know how to find area, length into breadth. It's a square sheet, L into L, L square. This is called mod of A vector or A. Now what about direction? Direction of area vector. It is written with n cap and it is outward drawn normal. So draw one line which is perpendicular to S1 or A1. See, this line is perpendicular to S1. Now you have two options: into the cube, inwards, or out of the geometry, outwards. So answer is it is outwards. So we will write as n cap. This outward direction is n1 cap. So what is this n1 cap? This is direction of S1 vector or area 1 vector. Remember, area vector can be written as A vector or S vector. Area vector or surface area vector. So this is area 1 or surface 1, surface area 1. So this n1 cap gives the direction of area 1 or S1 vector. Breathe in. Remember on this, focus on this line. Outward normal. See, for this face S2, this is outward as well as normal. So this is N2 cap. Similarly, it will be the direction of A2 vector or S2 vector. Likewise, you can write direction of area 3. This is N3 cap, outward normal. Outward normal for S4, it is N4 cap. Similarly for S5 and S6. See this? This is one cuboid. As per the question, this is S1. So this is N1 cap outward normal of S1 or A1. It is outward as well as perpendicular. This is S2 as per the question, as per the diagram. So this is N2 cap outward drawn normal. This is S3 outward drawn normal N3. This is N4. Let us say it is N5 outward normal to this fifth one. And this is N6. Breathe in. Similarly, see, this is the geometry now. It is a hollow cylinder of radius R and length L. You know, it has three areas, three surfaces, A1, A2, A3 or S1, S2, S3. So first of all, see the values. A1 and A3, they are circular. So area is pi r square. This is magnitude of area. A2 is curvature. So A2 will be 2 pi r L. Now what about direction? Remember, outward drawn normal. See, for this area 1, outward line as well as perpendicular to area 1. So this is N1 cap. Breathe in. It is direction of area 1 vector. Similarly for A3. It is normal as well as outward. N3 cap. Direction of area 3. What about A2? You know, A2 is curved. See, this is curvature. This curvature part. So, this curvature having infinite points, so will be having infinite normals at all the infinite points individually. Like this. This is N1, N2 cap, outward normal. For this, N2 cap, N2 cap, N2 cap, N2 cap. For simplicity, for our convenience, we show it like this. This is A2 and at this point it is outward normal N2 cap. This is direction of area 2. See, for curvature, this is outward normal as well as this is outward normal. This is also outward normal. You can write anything. But for simplicity as a standard, we write this. Breathe in again. Now another point is, if single sheet, single surface is given, then what will you do? Like see, this is single surface. For closed, you can check outward or inward. For single sheet, we say both ways it is correct. You can write it as normal or you can write this one as normal. But for simplicity and nowadays it is becoming standard also, positive x direction. It is positive x direction, so we write it as I cap. This one is taken for the positive x direction, for positive y direction or negative y direction. See, as an example, breathe in again. See this most important example. You are given area of 1 centimeter square in XY plane. See, this is X, this is Y, and this area given in XY plane. You know how to change 1 centimeter is 10 raised power minus 2 meter. It is centimeter square, so whole square. It is 10 raised power minus 4 meter square. This is magnitude of area. How to find direction? Outward normal. You know Z direction. Z direction is represented like this. X, Y, and you write it with dot dot. This is Z direction. Really speaking, this is dot perpendicularly outwards. This is Z direction. See this pen. This is Z direction. This red pen is representing Z direction perpendicular to X as well as perpendicular to Y. This is positive Z direction. And in the reverse direction, it is negative Z direction. X direction you call it I cap, Y direction J cap, Z direction you call it K cap. You write it with dot dot line. Dot dot represents this is out of the plane, like this. Now this is z. Either write with dot dot or write with dot. So this is z direction. See, positive z direction as well as negative z direction perpendicular to this area. So as a standard we write this is n cap. So n cap matches with z direction, meaning k cap. So we will write this area as area vector is magnitude of area into n cap. So area vector for this is 10 raised power minus 4 meter square into n cap. So this n cap is outward drawn normal. Now there is no outward, this is single sheet. So it is normal to the single sheet, which is matching with positive z direction. So this n cap is positive z direction. So we write it k cap. So this A vector is written as 10 raised power minus 4 k cap. Of course it is in meter square. Breathe in slowly and gradually. Now have a trick. You know all the three directions are mutually perpendicular. X, Y, Z all are mutually perpendicular. So whatever plane given to you, focus, it is X, Y. Out of X, Y and Z, X, Y given. What is not given? Z. So there will be Z direction k cap. This is the trick. See, for example, if I say area in YZ plane. So what is not given? X. So direction of area vector will be XYZ. Out of XYZ, X is not given. So I cap. Got it?